Good morning, hello. I realized that I'm wearing a slightly green shirt because my sweatshirts are all in a wash, and that makes me slightly transparent. Although it is a much darker shirt than my background, so I wonder if I can actually fix that. Where are you? Let's see. It was not that. That. Filters. There we go. Turn the similarity down just a tiny bit. Oh, there's... Camera can go just a tiny bit up. Oh, come on. Stop falling down. Oh, that's what my problem is. I have Velcro on the top of this this computer because these days the monitors are not quite nice. Okay, so I can make that go away, and I am still not transparent. So perfect. Okay, I'll take it. So today the plan is to be doing a little bit of a longer day because I'm taking the rest of the week off. It's just so slow at work after that holiday. And the rest of the team's got it, so I haven't taken a really solid vacation all year, so this is it. All right, so what are we doing? Where are we going? We are doing jumping, so we have a problem right now. When I try to jump, I believe I can just jump forever. No, that was the wrong one. I don't have a way to exit the game once we've started playing, I believe. I need to change that from a hash map to maybe a hash set or something, so that way we can make sure that we have the floor. Also, I need to figure out this this jittering thing. I'm not exactly sure what's going on there. Ooh, look at that. Okay, so we got an error. Use a flag on the player. Oh, no. That's just the debug. That's just the debug telling us what we need to do so that way we can jump, because the player velocity.y is a lot more than what we're checking for. It's certainly not 0. So let's go ahead and do that. So creating a flag, I'm thinking that the flag is probably going to be a string, which means we can compare it against an enum that we have the strum 2 string on, which should work out. That means where do I want to put those? Probably under names. We'll create flags. This is not going to be just flags. This is going to be the entity state. All right, so what are the states that we know that we're going to be in? Well, to begin with, we're starting in a falling state. So that's where nothing is beneath us and gravity is affecting us. Then we're going to be in this standing state. When we've, hit the ground. And I don't think we're going to have a jumping state, because that command, well, does that put us into falling? I think jumping puts us into falling state, so we just switch back and forth between these two. We're gonna need the strum. And we're probably going to need both. So as string ref and toString. Now is there's into static string? I don't think that's what we want. That could be interesting. All right, so we give ourselves this enum. Then I'm gonna want to store this away as part of our entity, meaning specifically for our player. So let's give it a component name. It's gonna be the entity state. We also need to go to the main library and register this. And then we have to set up the insert into world to handle the state. And this is going to be a string. I suppose we don't have to string it over there. We can string it in here. So this is going to be an entity states. Oh, and here we're going to turn it into a toString. And then return self. Okay, then our insert happens. Oh, wait. No. Here we store it as just this. The toString happens down here. So with component name, it's going to be component names, entity state as ref, and our data is going to be state.toString. There we go. That's what we wanted. That should allow us to now insert this into the player. So this is going to be play and loaders. Okay, so here's player. Okay, so when is the player? We set that you're a player. We also set state. And yeah, you're falling to begin with. We're going to initialize you as falling. So, an interesting idea. Now that I have this this like state flag that we can add to the entities, we can then make it so that gravity only affects to things that are falling. So we can now head on over to gravity. So the apply gravity system. So we get the gravity amount. Okay, so affected. So it is things that are affected by gravity, but we're also going to want to get their state. Now, is that true? Or Yes. We want affected by gravity and their state. So we want the states. Okay, so we can cast that down. Now we need to convert the we need to convert this into an actual state. So I'm thinking in entity states, we want to have some kind of like from string. Hello, Chantilly. How are you doing this morning? You're good. It is Thursday. It is Thursday. We're getting closer and closer to the end of the week. That's pretty awesome. All right, so I'm gonna do this from stir where we can then convert this back to whatever it's gonna be. So let's see. We're going to match on self. Oh, I guess we should match on entity states. I don't know if it... Really? Oh, we're gonna match on the string. There's like no way to fill these match arms. It is the stir, so we should be able to do falling. So if we're falling, we're gonna return self falling, and if it's standing, we're going to return self standing, and if it's anything else, we are going to return, let's have like an unknown. Self, we're in an unknown state. Good luck with that. Okay, so back to here. So we cast this. If we're affected by gravity. So another thing that I'm noticing here. So if we're affected by gravity, now this makes me wonder if I could throw this into another oh, but I guess we could have multiple things affected by gravity. So yeah, that doesn't necessarily work. We could potentially put this into an array, or like a function, and it returns a vector of indexes for us to check, but that, I don't know if that's helpful. It would clean up like this code, but only a tiny little bit of it. It would just basically make this check in multiple places. Now what I could potentially do here is switch this into an iterator and then use a filter on it, which then first filters by whether or not we're affected by gravity. And then then for the rest of them, it's going to be the ones that are affected by gravity, so then we do the thing. That could also work. So what do we want to do here? So we're going to take a wrap states We also need to check to see, so if we're affected by gravity and, okay, so we need comparison on here too. So partial equal. And we need to get the actual state. So let the state equals, this is going to be entity states from stir. This is going to be a reference, and we have to dereference it because, you know, fun. I wonder if I can get away with, okay, let's try this. If I just put in wrap states, borrow, so it's a ref with this string. Now you're gonna yell at me because you take in a stir and this is a borrow here. So can I say that you impl deref? Do I have to give you like a type? Why can't I give you a type? Oh, because like that's just the trait for that. I don't think I can deref into string or something like that. Yeah, okay. So that's not too bad. Now what I could do is I could just say, hey, this is a ref. We're gonna take in a ref with a string inside. And so we're going to get we're just going to do this stuff here. So this is dereft, but then I also want a reference that I don't have to do like a toString here. Expected type, a reference to a string found static string. Let's see. And then this is expected a string found a stir. Okay. So if I to own these, for example. Oh, I don't think I can to own them. Right. Because I don't think I can actually run code here on the left. I think that was the problem of like doing something like this. Yeah, expected like a comma. Can't actually run code here. So if I dereference you out and then I reference you again, expected a reference to a string found this stir. This expression has type reference to a string. Okay, so that's too bad. Okay, I was really kind of hoping that would work out for me, but I guess not. Let's bring this back here. Let's do it over here, and then I think it will work. I have an error, but I can't see the red. It's near the bottom. Oh, here it is. Okay. Oh, because I have this and. So I think it's now working. So we get our state out. So then, okay, and state is equal to entity states falling. So if we are falling, then apply gravity to this entity. So if I run this, we should still fall because we start in a falling state. And now we're still applying gravity, so this is fine. But what I want to do is, as soon as we hit, so we handle collide with platform, if we're falling, okay, so when we do this to grab the entity, so game entity, I want to get the state, if there is any. So hub, do I want everything to have a state? No, probably just the ones I care about, right? So state, then in that case, it should be an option. And then this is going to be the same thing that we have here. But we should actually, when we grab this in, pull in the real state. It's getting hard and hard enough for us to actually do. So game entity, yeah, because like there's no constructor on this. Now camera. Camera has state, but none. So that's fine. Query platform. Platforms also have no state. Query player. Player does have a state. So we need to query states. Okay, get the states out of there. Grab this here. I then need to convert this over, which shouldn't be that big of a deal. So then we're going to have state is going to be a sum entity states from stir. This is going to be the wrapped state that we borrow. Okay, so far so good. This means that in it didn't stay open. Collide with platform. We should now have access to that state. Okay, so we're querying the player. So, okay, if we get the player, we know that we have the player there. If we know we have a player, we know it has a state. So we can grab this state out too. Which means, okay, so for platform, Basically, we can do an early exit if we're not falling. So if we can just do this up here, if player dot state unwrap this is not equal to entity states falling, then return okay. Player state partially moved due to this method call. I don't want to move it. What happened here? Okay, so entity states does not have the copy. Let's see if we can fix that. Okay, that makes you happy. And then, oh, you know what? I don't want to store the original in here. Okay, never mind. In entity states, no, not entity states. In game entity, I actually want this to be this one so it can be changed. So we can update it. So it can be a string. But what we should do is have maybe a function that like returns the actual state. So a function, our state, we're gonna return an option within entity states. Okay, so we can do entity states from string. We can do self dot. I guess it'll be the it's data wrapper already. So okay, it's already been cast. So we can just do this self dot state dot. We're gonna unwrap it. No, we're gonna question mark it. Then we can borrow it. And that's what we return. No, we have to return a sum, don't we? So if it's a none that we have, this question mark is going to force a none to be returned. This means in query player, we don't get to do this entire entity states from string. We just pass in this wrapped state. Which now means that this isn't quite as easy, but maybe it is. So we're gonna do player.state as a function and then unwrap you. And then that should works just the same. Okay, perfect. And then if we collide with the platform, I notice that we reset our player position. We should also reset their state to be set down. So let's this could probably be entity, game entity. Bruce, hello, good morning. Let's see, we're gonna have pub function. So set state. We could just do set state. This might work. I am doing very good, thank you. How about you? How are you doing today? Option, let's see, what do I need to do here? We just need to borrow mute it and set it to be whatever the new state is. So we need to take in the new state. So new state is an entity states. And our option, I'm gonna return this as an option because there's a possibility that we don't have a state. But what's in the option, I'm not exactly sure what we should return. So maybe it should be something like this. You're in a great state. Awesome, that's great to hear. It is morning here in America. I'm in Mountain Time, so that is 7:32 a.m. in the morning. Where are you in the world? Okay, so we have set state. We're doing this. Okay, so now we can do self.state. We're going to essentially need to unwrap it, but I can just, is it dot question mark? No, it's self.state question mark and then dot borrow mute. Algeria, well, welcome from Algeria. I don't know if I've had any other Algeria viewers, so awesome to have you here. Okay, so there's that, and then I need to dereference you so that I can set you equal to the new state that toString. And then we're gonna return a sum with nothing in it. Is Rust development hard or easy? That's a tricky question because the answer is yes. I would say that Rust is hard to learn, but then like development in it, once you know it, can be pretty easy. But that learning curve can take a bit. It's one of those languages that I sort of feel you either you love it and you can work with the pain, or you hate it and you just want to go to another language that is not quite as like opinionated. Epic Blar, good morning. You'll second that Rust is hard to learn, but it's so much easier to develop stable programs once you know it. I can't remember what it's called, but there's this bell curve that can describe when you're building software, there's gonna be like a lot of failures, and then suddenly just everything works, and then a lot of failures again as like, I don't know, changes happen. Rust tends to make it so that the bell curve, it's like quicker to get to that top. It works really well. And then it's also quicker to discover that it's not working anymore. But the caveat is that's only if you know what you're doing. If you don't know what you're doing, you could go down all sorts of different paths of like, well, I want to just try this. I just want to do this. I just want to do this. And the compiler is telling you, no, that's not how we do it over here in Rustland. You're going to have to learn the way I want you to do it. And if you don't want to do that, then have some errors. Okay, so now we have this set state. I can come back here to collide with platform, and I don't even need a function for this anymore. We already have a function over there. How do you know which is the right way to do it? Well, to begin with, the it compiles and works is not a terrible, like it's not terrible in Rust. That doesn't mean that it's not great, or that doesn't mean it is great, but it does mean that it's like guaranteed to work. The other thing is Rust tends to make it really easy to refactor because it's almost like you have a bunch of tests that are pre-written for you that is the compiler itself. In a way, Rust tells you how you should have been doing it all along with other languages as well. Although, so a little bit of caveat with that, it assumes other languages can do some of the things that Rust can do. Like, for example, result types, like with this option, the option that I showed in like the last function, the result here, can't do that in JavaScript. As far as I can tell, can't do that in Python. You can make your own types and return them. But yeah, like there's some things that are like not unique to Rust because functional languages have them, but not all languages have every feature of Rust. Where can you learn it, Bruce? Excellent question. You know what? I should add in a command for the book. I don't have a command for that. Let's add that in. Okay, over here, where is chat commands? Custom add command, do book, and this will be learn. I guess maybe book is not right. We could do Rust book. Rust book. There you go. So learn Rust by reading a free book online. And then I need to go grab the URL. So rustlang.org. Get started. No, learn. That's what it is. So rustlang.org, learn. Here's this getting started with Rust. We have read the book, course, and then Rust by example. I would recommend read the book. Even if you're a established programmer and you've been doing this for a long time, I would still recommend at least the first, 8-10 chapters of the book. Maybe you don't have to do the final projects, but I still recommend reading, at least reading through it all and doing every exercise because that's going to be really important. Everyone can do it. Cooldown. Let's do like a 5-minute cooldown. So submit that. Now we can do, let's book. Speaking of books, did I see that John, who is writing a Rust book, he wrote it and published it? Yes, I did. And it's apparently the exact same content of all those streams and videos he's been doing, except, more. So I'm really excited about that. I want to read that book myself. I have like a backlog of books that I want to read. So I will eventually get to it, but it might take a while. You pre-ordered it, so you got the early access version. Oh, nice. Yeah, I didn't even notice that he was creating it until he he just announced it on Discord and then on Reddit and everywhere. And I'm like, yes, he deserves that too. He's worked so hard for the Rust community. I wish him the best with that. Which books am I talking about? Let's see if I can find it. Let's go over to Discord. The Rustation Station. So this is... Here it is. So I'm writing a book. Does he have a better link directly to the book? No. So that takes us to Twitter. Here we go. And then it is from the No Starch Press. So here is the name of the book. It's Rust for Rustations. Looks like it's let's see. Print. Oh, you can get the print book. Well, I don't know if I want the print book. I just have so many books, so much stuff. I don't know if I want a print book, but the early access ebook, $31.99, that feels like pretty worth it. No, wrong one. You go over there. You go back over there. Gonna start learning it right now. Awesome. Well, welcome to the Rust Club. I think one of the big things is there's a lot of communities online that are very, very willing to help. So in Discord, there's the Rustation Station. There's a little bit less like questions for help, but there's also a official, is it official or unofficial? Rust community. So there's a Rust programming language here. So, and they have a Rust beginners, which is super, super, super awesome resource. I don't remember what the link is to like get access to it. And then let's see what else. Then there's just a bunch of streamers who are super, super happy to like answer questions about Rust. Oh, Rust user forums. Yeah, I've you know what? I don't think I've ever been on there. And there's 2 Rust subreddits if Reddit is your thing. There's Learn Rust and there's Rust, which is awesome that we got that name because the game Rust just has Play Rust. And so they constantly head over and try to post content over there and then just get told, yeah, sorry. Okay, so if we're colliding, so was player above? Okay, so look at this. If we're left and right, we want to continue falling, but if we're above, then we want to stop playing. So that means we want to say player dot set state, and the new state is going to be an entity state standing. I don't want to go back anymore. I'll just go back to this. Even if I do this, I wonder if I should do like something like 0.1, so it's not as jittery. Like 1 full pixel is a lot. They should rename the programming language Rust to Counter-Strike to avoid the confusion. Oh yeah, I mean absolutely. How about just CS? They should just rename it to CS. That's not going to create any confusion with anything else. Then we can both confuse the Counter-Strike community and the computer science community all at the same time. You are not mutable. So, okay, we get the player. We need to make the player mutable. And then I think we're good. So if we come back to this and we run you, I should fall on the ground. It shouldn't jitter once it hits the ground anymore. And I should, there you go. Now I'm just standing here. Now I can move left and right. Now it still jitters left and right, so that's cool and fun. I do wonder if setting VSync will fix that jittering. I am worried that it won't though. I want to head over here. I want to take a look at our update loop. Yeah, so we're targeting 60 frames per second for update, and then for main VSync, I want to turn on just to see if this helps. So VSync is gonna sync the sync everything to my display refresh rate, which I think is 60 frames per second. I don't think that this monitor is anything crazy, like, you know, less than that. There we go. Now we've got smoothness. And we can see that timer FPS down there. That's nice. So if I wanted to get smoothness with a lot more frames, I need to do some calculations to make sure that we're to like fix some other things. So okay, we're good here. Now I want to jump. When I hit jump, if we're in a standing state, then we can start jumping. So if we're in a standing state, we can jump. We have the systems manager. We have a jump system here. So when we do our query, we get our player, so we can now get the state. So I don't need this debug anymore. So we get the velocity Y, so we can update that. I don't think we need, okay, so here's where we're gonna choose whether or not we're gonna be jumping. So I don't even need, so I don't need the velocity to check it anymore. I just need to do if player dot state, so get that. We can unwrap U because we know it is a player. Then I want to get, let's see, check to see if you're equal to entity states standing. So if you're standing, oh, I'm using a state machine for this. That's good. They can easily add double jump power-ups. Yeah, actually, that's really interesting. I can do all sorts of interesting things with this. Now, this is currently a finite state machine. So I'm not sure I could turn it into a non-finite state machine. So for any of you who don't know a finite, like when we say finite state machine, the word finite, part of it means there can only be one. So, and then state machine is just a really, really, really simple way of just saying tracking a state of something. So like jumping mode. So basically the string jumping gets set to that, and it can only be one thing. So jumping. And then there's finite, it can only be a certain number of things too, and only one thing. So that's what this is. Finite state machine. It's actually a surprisingly simple concept, and enums and Rust make it extremely easy to implement them. So if we're standing, return okay. Well, no. If we're not standing, return okay. Then we can jump. Now, if we jump, we need to, okay, so we add a jump force. We then also need to then immediately turn ourselves into falling again. So we're gonna do player dot set state, which means you need to be mutable. The new state is going to be empty states falling. So now the player is in a falling state. Okay, let's see if I can jump now. We fall down, less jittery. But how can I tell if I'm moving? Okay, there I am. And there we go. Now I can fall. Now, can I jump twice? No, I can't. I can't jump until I hit again. And if I hold jump, that doesn't work either because I'm only listening for button down events. And I'm not looking for button ups. So now I can jump like this. I can move really fast, left and right. Perhaps a little bit too much. State machines is a really good way to describe program flows in high assurance code. Oh, look at that. If I go off the edge, I don't fall. That's, So this is the problem about adding in a state machine. Now I need to like make sure that the state gets updated properly. Otherwise, the game gets a little bit confused. It makes verification much easier. It does. It does make verification much easier. We just have to remember to update it properly. Okay, so I can jump. I think let's take a look at our issue here. User can't jump in midair. So there we go with that. So I want to take all of this code and commit it, but maybe before we do that, let's also take care of any warnings that we have. That's it. That's all of our warnings. So I can close all of these windows down. And okay. Player can jump once when standing on a platform. All right. So